In this video, we are going to discuss decision structures in Python. Decision structures include if statements or if blocks, if else statements, and if elif or else if statements. The first thing that I want to do to continue from our work in the previous video, in case you are using a different folder to save your files, and in this situation I'm actually going to do some modifications to how I save folders, or save my files. So I'm going to click over here under the Explorer, click Add Folder, and I'm going to go up to the desktop and click Python Exercises, which is what we did in the previous video. And you'll notice that it opens the 4 exercises we did in the previous video. I'm going to create a new folder, and I'm going to call this folder, let's call it, to follow along, let's call it Chapter 2. And I'm going to drag and drop, don't ask me that again, yes, move. I'm going to drag and drop the files I did in the previous video into the Chapter 2 folder. Alright, now they're all in there. I'm going to close this. Alright, and I'm also going to create another new folder called Chapter 3, which I will put the exercises, the files that we create today. Alright, I'm going to roll up Chapter 2 by clicking the down arrow, click Chapter 3, and then select New File. I'm going to call this file E1 underscore age classifier .py. Can't forget the .py. That lets Visual Studio Code know what file, and as an extension to that, what programming language we're using. Alright, let's call this exercise 1 age classifier. And let's take a look at what this program entails. Write a Python program that asks the user to enter a person's age. The program shall display a message indicating whether the person is an infant, a child, a teenager, or an adult. Use the following guidelines. If the person is 1 year old or less, he or she is an infant. If they are older than 1 year but younger than 13 years, he or she is a child. If the person is 13 years old but less than 18, he or she is a teenager. And if they are over 18, they are an adult. Alright, let's take a look at the output here, an example output. This program determines if a person is an infant, a child, teenager, or an adult. We ask for the person's age, they enter it, and we output that this person, in this case a 37-year-old person, is an adult. Alright, let's pseudocode this out. That looks better. Alright, pseudocode. So the first thing we're going to do is output the program's description. And then we're going to input the person's age. And based on that input, we were going to determine if the person is an adult or a teenager or whatnot. So let's do if person's age, let's see, is 1 year old or less. So that would translate into 1 less than or equal to age less than or equal to 1. There we go. And if that's the case, then we'll say output, sorry, output person is infant, or is an infant, I guess I should say. Alright, so that is age less than 1 year old or less. Okay, so yeah, that will work. Next one. And I could do this as a series of if statements. I could also do it as if else, or rather if elif statements. Which should I do? Which should I do? Which should I do? Well, truth be told, I could probably do a series of if statements. But to be more robust, let's do else if person's age is less than or equal to, oh, I might have to do this again. It's older than, okay, if age is greater than 1 and age, or not, I'm just going to put age instead of person's age. Age less than, but younger than 13 years. So less than 13. Then that means output person is a child. And I'm going to drop persons from all of these so that it's just, I can leave person's age there, but I'm going to drop off persons in the, don't forget the then. I'll drop off persons in the evaluation expression. Alright, let's move on to the next else if statement, or else if block. Else if age, let's see, if the person is at least 13 years old, greater than equal 13, but less, and age less than 18, then output person is a teenager. Well, truth be told, 19 is still considered teenager, but anyways. And then finally, I could do something like else if age greater than 18, or greater than or equal to 18. But I don't need to do that. I could simply do else. In other words, if the person is not less than or equal to 1, if the person is not a child, if the person is not a teenager, then the person has to be an adult. End if. And there we go. Now, I will tell you there are several ways to write this program. There are several ways indeed to write this program. And I'm going to go through a couple of the ways. I'm not going to say that any one of these ways is better than the other, but I will say that there's probably more robust way. There is a more robust, more elegant way of writing this program than there are compared to some of the other ways. So the first thing, of course, that we will need to do here is simply print out the purpose of the program. And let me close that part. This program determines if a person is an infant, a child, a teenager, or an adult. Hopefully, I didn't make any typos. Person is an infant, a child, a teenager, or an adult. And then I'm going to do a new line character at the end to get the separation between the program's purpose and the input. So all we're doing here is outputting program's purpose, and then get age from user. So we'll input the person's age using, well, we have to create a variable, and we could call this person age. I think I'm just going to call it age. equals input and what we want to ask the user, which is, we could, well, in this example I've used person's age. It could be enter your age or something like that. Just something to prompt the user to enter. Be sure to put the space after the colon so that there's separation between the prompt and the user's input. Alright. Alright, and now we need to determine person's classification, whether they're an infant, a child, teenager, or an adult. Now, I'm going to do it the first way using only if statements, and it's going to be 4 separate if statements. So, we are going to have to convert age to a numeric value here. Probably could do integer, hoping that the user never enters in 37.5. So I think it's probably safe in this example to do integer instead of float. So now age is an integer, or at least when the user enters something. We could do if age, and in the pseudocode I do less than or equal to 1. There is no in Python, there is no then keyword. Instead, we use a colon, which is the equivalent to then. We hit enter. Notice that the cursor tabs in for us. In Python, anything inside a code block, and in this case we have an if statement code block, has to be indented. Otherwise, it's in Python, it's not considered part of the code block. So, if age less than or equal to 1, we would output, let's see, print age, comma, and then I've done dash year old person is an, and in which case we would put infant here, period. Now, I'm not going to do the else if or elif statements here. I'm just going to do 4 if statements. If age greater than, how do I put it, greater than 1, I'm just going to look at my pseudocode and go based on that, and logical and, which makes a compound expression, age less than 13, colon, print, and I'm actually just going to copy this and slightly change it to child. If age, and I'm looking back at the pseudocode, greater than equal to 13, and age less than 18, colon, printing, I'm going to paste in this so that it's teenager. Oh, teenager. Ager. There we go. And then one more. If age greater than 18, colon. And then we'll print out adult. Is a teenager, is a child. Now, because I've used separate if statements here, let me make sure that it's clear that these are separate. And this works. It's not the best way of doing it, but it does work. So when we run this, I'm going to do 14 for the first time as soon as it gets up to the prompt. Okay, 14. Now, I forgot to put in new line characters, and I'll fix that in just a second. Notice that I have separation between 14 and my dash. So to fix that, I'm going to have to pass in the sep argument to each of my print statements to eliminate that extra space. And I'm also going to do print and then basically printing nothing, just an empty print function call, so that there's separation between my input and my output. I'm going to run this one more time, and this time we'll do 35. 35-year-old person is an adult. And the program works exactly as we would expect. I'll tell you what. If you notice that next to our line numbers, to the left of that, if you put your cursor down through here, there's like a little red dot. I'm going to put a little red dot here. Basically, I clicked it. Notice down here at my breakpoints, I have a breakpoint on my file now. So what this means is when I run it this time, it will stop execution at this point and wait for me to tell it to continue. And this is going to allow us to see what the program is doing. It's called stepping through your program, and it's a form of debugging. Alright, it's very useful if you're getting unexpected outputs. So let's start debugging. It's going to ask me to enter an age, and let's do 14 so that I get the third one there. And notice that the program breaks right here, and I get these at the top of my window. Notice that I have step over. Well, I also have continue, step over, step into, step out, and is that restart? And then stop, of course. So I'm going to actually click, and this is the one that you'll mostly do, F11, which is step into. So it goes down to the next line of code, and it's evaluating if age less than, and notice that when I put my cursor over age, it tells me what the value is. If age less than or equal to 1, and because age is 14, it is not less than or equal to 1, it will skip the print statement and go on to the next statement. And again, put your cursor over age because it will tell you what it is, 14. If age is greater than 1, that's true. Now, for this to also be true, it has to be true on this side. If age is less than 13, well, that's not true. So that gets skipped. And we go to the third if statement. If age is greater than or equal to 13, that's true. And age less than 18, that is true. True and true equals true in logical AND. So this gets printed out. But we're not done, because I have another if statement. If age is greater than 18, well, age is actually 14, so it is not greater than that, in which case that's skipped and the program finishes. And that is stepping through and using the debugger. I'm going to take this off for now. That is stepping through your program. Super useful to find problems in your code. Now, this is not the best way to do this. This is a way to do this. It is not the best way. So, let's do it a different way. Using if elif or else if statements. So the first part will stay the same. So it will just be if age less than or equal to 1, colon, and then I would print out age, comma, and everything else that's here. And I'm actually just going to copy this and paste it over. Now, instead of having a separate if, let's do elif, which stands for else if, elif age greater than 1 and age less than 13, colon, or then we would print out this part. All right. We move on to the next one. Elif, or else if, and let me scroll down so I can see that part. Age greater than or equal to 13, logical and age less than 18, colon. I'm just going to copy. Paste that in. And then finally, else, which in other words, if it's not one of those three categories, they have to be 18 or older. So if you take a look at this, I have reduced the amount of code that I have to write. End if there. So I can get rid of that now. There we are. It's unhappy with this. Why is it unhappy with that? It's going to take me a second to remember. Oh! I got you. I'm missing my colon. There we are. Oh, so even the else has to have a colon. Alright, so when we test this again, and let's do 10 this time, it should output 10-year-old person is a child. Good. It does exactly what we'd expect. Now, notice something interesting here. Now, I will say that using if, elif, or else if is the best way to do this. But notice that we are repeating ourselves a lot. This line here repeats several times. Now, it changes depending on whether it's an infant, child, or teenager. In programming, it's usually a bad idea to repeat ourselves. So let's make it so that we don't repeat ourselves. And to do that, let's create a variable here called, I'm going to call it age class. And for age less than or equal to 1, I'm going to set it to simply infant. And I'm going to get rid of that print statement. And in fact, I'm going to paste over all these. And this is a teenager. This, oh, no, it's not a teenager, that's a child. Sorry. This is a teenager. And this is an adult. And instead of having and repeating myself all those times, and I'll have to give me just a moment. So I'll have to, since I got rid of it, I'll have to take a look at what it's supposed to say again. And only have one print statement at the end. Print age, comma, and then dash year dash old space person is an, and then after that, comma, and then my age class. That stands for age classification, comma, and then double quote, period, double quote. And I will have to pass to it the separator argument equal nothing. So now, instead of repeating myself several times up here, I'm only getting the one word that I need and outputting it down here. Now, I will have to do a couple of things since I've made my separator nothing. I need to put a space there because otherwise the is a, and then age class, and then so forth. So we do have a grammatical error here, which we will talk about how to handle in just a moment. We'll fix that too. So we do have a problem, and I want to run the program so that you can see what the problem is. I'm going to enter the age of 10 again, and notice that the program kind of oh no, it actually did exactly what I expected. It actually did what I did not expect it to finish or output that. That's actually quite interesting. I expected age class to be out of scope, like in any other programming language, because I've defined age class inside of the if statement, and in which case I expected it to not be visible outside of the if statement. So it didn't, it still worked, but I didn't expect it to. But let's go ahead and define age class outside of the if statement as nothing, just like you would in other programming languages. So that, well, for one, I feel better about it, and hopefully that won't be a problem in the future. So this defines age class outside of the if statement, and then we reassign it these 4 times here. And that's just so that age class already exists and is in scope properly. I expected it to actually error there, but it didn't. Python's an amazing language. Alright. So entering 10 years old, or entering 10, is perfectly fine. Now, if I enter 1, notice that it says 1-year-old person is a infant, which is not quite grammatically correct. It should say an infant. There is a couple of ways we can handle this. I guess the easiest way, and we would be repeating ourselves just a bit, but not too much. If age class is equal to, remember 1 equal sign is assignment, 2 equal signs is the comparison operator. So if age class is equal to infant, logical or, because either one of these can be true for the whole thing to be true, if age class is equal to adult, colon, then we would want to print an instead of a. And then else we can print a. And then we'll end the if. That comment there is just for clarity purposes. It's not required. Just meant for clarity so that everyone understands what's going on. I don't know. I was doing it capitalized. I guess I should do it lowercase. I think that would look better. Alright, so now when we run this and we do something like 27, it will print out 27-year-old person is an adult, which is grammatically correct. And if we do something like 15, it prints out 15-year-old person is a teenager, for teenager and child, as we would expect. And I will say that we kind of went further than what the requirements of this program asked for. However, we have definitely accounted for all the various edge cases as it relates to this program. All right. I'm actually going to close this program now, or close it in the editor. Let's see, what other programs do we have? Um, let's. I'm going to skip number 2. Feel free to do you want to skip it or just go ahead and do it? Let's do number 2. It's not too bad. I won't take as long on number 2 as I did on the first one. Alright, so let's click chapter 3 and go up here to new file, and we'll call this E2 underscore magic dates .py. Can't forget the .py. And this is exercise 2 magic dates. Alright, the date June 10, 1960 is special because when we write it in the following format, the month multiplied by the day equals the year. So 6 times 10 is 60. Write a program that asks the users to enter a month in numeric form, a day, and a 2-digit year. The program shall then determine whether the month multiplied by the day is equal to the year. If so, display a message informing the user the date is magic. Otherwise, it should display a message saying the date is not magic. Alright. I'm not going to pseudocode this one out to save some time, but I'm hoping that based on what you saw in the first video, you would know how to handle pseudocoding an if statement. So I'm just going to jump right into this one, where I will print this program determines if a date is magic, and we'll have to handle the quotes here. So I'm going to put a backslash before the quote, the first quote in magic. I'm going to put a backslash in front of the second quote in magic, and then of course that double quote corresponds to the first double quote. That's the escape sequence for a quote. Backslash and then a double quote. Alright, and then I'm going to do right next to the escape sequence for the double quote, the escape sequence for a new line character to get some separation. Let's call this month, the variable to hold the value that I'll enter for the month, and input. The prompt will be enter a month, colon space. We want that separation. Now, we will need to convert this to something that we can calculate, so let's throw it the inputs function inside, or rather, yeah, the input function inside the integer function to convert it to an integer. For day, we will do int input enter a day. We probably could be more specific here, but we'll follow the instructions. Year equals int input enter a year. And there are our 3 variables for the calculation. Now, this is our get input from user. Now we need to determine if the date is magic. Now there's a couple of ways we could do this. I'm just going to do it in an if statement. If, let's see, what do we have to do? If the month multiplied by the day. Okay, so if month multiplied by day is equal to year, so in other words, when we multiply these two together, if it is the same as what they entered for year, colon, the date is magic. So we would print, we have to format it a bit, the date, comma, month, comma, and we're going to have to do some string manipulation here. Day, comma, and then forward slash in double quotes so that it's a string, and then year, comma, is a magic date. We're going to have to come back and do, well, let's go ahead and do it. We have to pass the sep argument so that this stuff is all pushed together, and we'll need a space there, we'll need a space there, and I think that's it. Else, if this results in, so if it is the same, this results in true, and we do this. However, if it's false, and I'm just going to copy this so I don't have to type it in again. The date, blah, 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 is not a magic date. And we drop the exclamation point for a simple period. Alright, so let's step through right at the if statements. So I'm going to put a breakpoint there, go to debug, and let's run this thing. I'm going to enter one that is not magic. So 1, 1, 10. So if it's let's say it's like 2010 or something, right? So that would be January 1st, 2010. All right. Let's see what the value of month is. Month is 1. Day is 1. Year is 10. So 1 multiplied by 1 does not equal 10. Let's step into this. It will skip the first print statement. And because it is false, go to the second print statement and output that. The date 1/1/10 is not a magic date. Now, again, oh, we can actually do, well, we could do print here. That would fix it. We could also do new line statements right here and here, and that would work too. All right, let's do one that is magic. Let's see. So if it's 7/10/70, that should be a magic date. Yeah, 7/10/70 is a magic date because when I multiply the month by the day, or 7 times 10 gives me 70, and if that is equal to 70, which it is, it prints out this, the first print statement. All right. Okay, we did that one in about 8 minutes. Let's move on to number 3, and I'm probably will stop there and leave the other 2 for you guys to work on your own. So we'll do 3 of them, which should be enough for demonstration purposes, I believe. I'm going to go back to the Explorer. I'm going to close this. Make sure Chapter 3 is selected. Click New File. Button there. And let's call this E3 Money Counting Game.py. Alright. So this is exercise 3. Money counting game. Alright. Create a change counting game that asks the user to enter the number of coins required to make exactly $1. The program shall prompt the user to enter a number of pennies, nickels, dimes, and quarters. If the total value of the coins entered is equal to $1, the program shall congratulate the user for winning the game. Otherwise, the program shall display a message indicating whether the amount entered was more than or less than $1. Let's pseudocode this out. All right. First, of course, output program's purpose. And then we input number of pennies. We input number of nickels. We input number of dimes. And we input number of quarters. And I guess the easiest way to do this would be to calculate in other words, how can I put this into words? Calculate the value of each. So calculate, I'm going to say face value by, and I'm going to actually do this in some parentheses to make it easier to understand, pennies multiplied by 1 plus nickels. Oh, let me put that in parentheses so it's, give me just a second. Yeah, I can maximize this for a moment. Nickels. And I probably should type out the word multiplied and then add, but I'm not going to, just to be quicker. Multiplied by 5, which is the face value of a nickel, right? Dimes multiplied by 10, which is the face value of a dime. I suppose we could be more specific here. We could do 0.01, 0.05, 0.10 plus quarters multiplied by 0.25. Okay, that will give me the face value of all the coins together. I'll probably call that variable total or something. Now, the goal is 1 or 1.00, right? So, if total, or let's call it if face value total is equal to, in other words, that 1, then output user wins. Else if face value total greater than 1, then output user loses and how much over they were, and we would get that calculation by subtracting face value from 1, and then else if face value total less than 1, then output user loses and how much under they were. So we would subtract 1 from, or rather face value from 1 to see how much, how far away they were. And that's it. that is the pseudocode to do this program. Unless I've missed something, I think this is it. All right. All right, let's start implementing this program. There's actually two outputs for the program purpose, but that's okay. Print money counting game. We'll do a new line after that. Then we'll print enter a number of coins to make exactly $1. And we'll do a new line after that one too. Now, I have some constants here that we should use to make our lives easier. I'm going to call I'm going to call it penny for penny equals 0.01. Remember, constants are all uppercased. Penny. Nickel is 0.05. Nickel. Dime is 0.10. Probably don't have to have that leading zero. Let's make sure. Yeah, I just liked, but it makes it easier for me to read. Quarter equals 0.25, and I'm going to create another one called, I could call it goal for the $1. I could call it win. I'm going to call it goal, I think. I'm not sure that's the best name, but I'm going to go with it until I think of anything better. Alright, so we need to get some values from the user. And that is these inputs here for each. So I called the constant penny. I'm going to call this pennies equals input, and we have to say number of pennies, colon, space. And we do need to convert this to a numeric value, and I think integer will be fine here. They're not going to put 5.5 pennies. At least I hope they wouldn't. You never know. Nickels equals int input number of nickels. Dimes equals int input number of dimes. Quarters equals int input number of quarters, colon. Alright, so that looks good. Happy with that. And now we need to calculate the face value of the pennies. I'm just going to call this total. And we are going to have to build a string, or rather a formula here. This is our get input from user, and then we're going to calculate face value of coins. Alright, let's start with pennies. Pennies multiplied by penny, I probably should call that penny value. Nickel value. Now I'm questioning myself because it's... Yeah, probably should, to make it more self-explanatory. Call these penny value, nickel value, dime value, quarter value, so that it's more self-explanatory. So, number of pennies multiplied by the value of a penny plus nickels multiplied by nickel value plus dimes multiplied by dime value, and I'm actually going to take this down to the next line, plus quarters multiplied by quarter value. Is it going to be okay with that? Doesn't look like it's going to be okay with that. Continuation character, make it okay? Nope. Alright, I'm going to maximize so that it's all on one line. There we go. These parentheses are not required, but it does make it easier to read. Okay, there's our calculation. And then determine the outcome. And we'll determine the outcome using an if statement. If total I'm going to change the goal to winning total. There we go. If total is equal to, remember the two equal signs for comparison. So if total is equal to winning total, colon, and give me a moment to see what it's supposed to say. Congratulations. Print. Congratulations. You won the game. Else if, or elif in Python, total greater than winning, oh, not Windows error, winning total, colon, print, you lost. You are, and now we have to do a calculation about how much over we are. You are total minus winning total over, oh, string, over. Now, you'll notice I have a cent symbol for it being 10 cents over, which that's great for that, but what if I'm like $1 over? And then the cent wouldn't be very accurate. So I'm going to use that. I'm going to instead do this and pass the separator argument. We'll do that. There we go. And then elif, or else if, total less than winning total, colon, print, you lost, you are, and then the $sign there. After that, comma, winning total minus total, comma, under, I guess would be the proper thing here. We'll pass the separator, or rather the sep argument as nothing, and do that. And unless I'm mistaken, I believe that's the program. Let's test it. Now we're actually going to have to test this one a couple of times. 0 pennies, 0 nickels, 0 dimes, 0 quarters. You lost. You are $1 under. Although, it's only printing out 1 decimal. And we do need a empty print right there to get some separation. However, I would like 2 decimal places here. So I'm gonna put that calculation into the format function. Remember, the first argument is what we want to format, and the second one is how we want it to be formatted. and I want it to be formatted with 2 decimals, so .2f. We're going to do the same thing for the one right below it. Pass what we want to format, comma, and then of course .2f here as well. .2f. Alright, let's run that again and see if it puts 2 decimal places in the dollar. 0 pennies, 0 nickels, 0 dimes, 0 quarters. There we go. I like that better. Looks better. Alright, let's go over. So we'll do 100 pennies, 100 nickels, 100 dimes, and 100 quarters. You lost. You are $40 over. Is that right? I don't know if that's right. Alright, let's bring up the calculator. Alright, let's see. Well, 100 pennies is $1. 100 nickels is $5? Oh, 0.05. Okay, so that gives I'm just going to write it here to keep up with it. That's $6 between the ones and the nickels. Oops. 100 dimes is $10, right? Yeah. So plus 10. So then we got 16 now. And it should, okay, when we do this calculation, if it's right, it should be $41. Because we subtract 1 from 40, that means we're 40 over. So 100 quarters better be, oh gosh, 15? I don't know. We'll see. 0.25. 25. Oh yeah, 25, not 15. So when we add that up, 25, it does give me $41, which is right, because we subtract 1 from that, because that's what we're shooting for, and we do indeed. That is correct. I wasn't sure. There we go. Good. Let's do one slightly... we already did one slightly under. Let's do one that's actually right. Alright. So if I do 2 quarters, that means 50 cents. I'm going to do 5 pennies. I'm going to do 2 nickels. 1 nickel. That gives me 10. Or rather, yeah, 10 in total. I'll do 4 dimes and I think 2 quarters. Yeah. And that will give me the winning total. Because 2 quarters is 50, 4 dimes is 90, 1 nickel is 95, and then 5 pennies is indeed $1. It's important to test all possible outcomes of your program. You'll notice that I've got 3 potential outcomes here. It's important to test all 3. Because you never know if one of the outcomes is or isn't going to do what you expect it to do. Now, the next 2 programs, I'm not gonna do those just because the video is already up to an hour. However, you'll find that the 4th exercise is going to use some similar logic to this program and the previous program and the program before that. Now, the 5th exercise is a little challenging program. It's a fun one, but you're going to have to think a bit. It's a good one, but you do have to think a bit. In the 5th one, you have to determine the number of days, hours, minutes, and seconds in whatever the number of seconds the user enters. But the problem is you have to do, for instance, whether or not you can do a seconds calculation, a minutes calculation, an hours calculations, or if it has to be a day calculation. So write a Python program that asks the user to enter the number of seconds and works as follows. There are 60 seconds in a minute. If the number of seconds entered by the user is greater than or equal to 60, the program shall convert the number of seconds to minutes and seconds only, and then so forth. It's a tricky one because you have to do a lot of converting. All right. I wish you luck on the next two programs if you choose to do them. But with that, I'm going to bring this video to an end. If you have any questions, feel free to shoot me an email. Apart from that, I hope you have a fantastic rest of the day.